Welcome to solverfy.
We are given in the problem that the bolt starts to fall 5 seconds after the elevator passes through it. Here first we will assume that at t equal to 0 the bolt starts to fall, and we will also assume that at t equal to 0 the position of bolt is at y equal to 0. As elevator descends vertically with a velocity of 5 meter per second, now we can write a relation for the position of elevator as velocity of elevator is equal to change in height divided by time. Let final position of elevator is y e. Here initial position of elevator is at origin, that is 0, divided by, and we want to find the position of elevator at time equal to t seconds, as we are given that the elevator passes through the loosely attached bolt 5 seconds before the start of motion of bolt. So we will have time here t plus 5, as we are given the speed of elevator is 5 meter per second. Now we can write position of elevator equal to 5 into t plus 5. Here I have neglected the units. Now we can write this as position of elevator equal to 5t plus 25. Now we can verify this equation by putting different values here. At t equal to 0 we will have ye at t equal to 0, that will be equal to 25 meter. That is when the loosely attached bolt starts its motion, then elevator already has already has crossed 25-meter distance in the vertical direction. Now we can write the similar relation for bolt. For bolt we can write delta y equal to initial velocity of bolt into time plus half into acceleration of bolt into delta t squared. Let final position of bolt is yb, and at t equal to 0 position of bolt is at origin, which is equal to as bolt starts from rest, so we will have initial velocity equal to 0. This gives us vi into delta t equal to 0 plus half into as the bolt moves with the constant acceleration of gravity, so we will have acceleration equal to at 9.8 meter per second square, and delta t that will be equal to t minus 0 whole squared. This gives us position of bolt after t seconds equal to 4.9 times t square. When bolt hits the elevator, then position of elevator and a bolt will be equal. Now by equating yb and ye, we will have yb which is 4.9 t square and ye that is 5t plus 25. We can write this as 4.9 t square minus 5t minus 25 is equal to 0. This is a quadratic equation in variable t. Here we will get two values for t, and the value which is required for us is 2.83 second. So this is the time after which the loosely attached bolt starts to fall will hit the elevator. Here this problem has the same scenario as that of example 2.8. In example 2.8 we have a car and here we have elevator. Both are moving with constant speed. The only difference is the elevator is moving vertically downward while the car moving in the horizontal direction. In the example trooper and in this problem the both starts their motion after a certain amount of time. Both are moving with constant acceleration. So example as well as the problem both have the same scenario. Now in the C part, first we will calculate the height that is covered by the bolt before hitting the elevator. We will take the relation yb equal to 4.9 t square, as we have t equal to 2.83 second. This gives us yb equal to 39.2 meter. So the bolt will hit the elevator after covering a height of 39.2 meter. Here we assume each floor each floor to be 3 meter. So the highest floor from which the bolt can fall if the elevator reaches the ground floor before the bolt hits the top of elevator, and this highest floor can be approximate by dividing the height covered by vault height covered by vault, that is 39.2 meter, divided by each floor is of height 3 meter. This gives us the maximum floors equal to 13. That's the answer.